Hello, I'm Dharshan from Caston. The topic is combination of shapes. Combination of shapes is shapes combined to each other. Formula for combined shapes. The first one is a combination of a cone plus cylinder. The total surface area for it will be CSA of a cone plus CSA of a cylinder plus area of circle, which is pi r L plus 2 pi r h plus pi r square. The volume will be volume of cone plus volume of cylinder, which will be 1 by 3 pi r square h plus pi r square h. The second object is a combination of a cone and a hemisphere. The total surface area will be CSA of cone plus CSA of hemisphere, which is pi rl plus 2 pi r square. The volume will be volume of cone plus volume of hemisphere, which is 1 by 3 pi r square h plus 2 pi d pi r cube. And the third object is a combination of cylinder plus hemisphere. So total surface area will be CSA of cylinder plus CSA of hemisphere plus area of circle. So it will be 2 pi r h plus 2 pi r square plus pi r square. The volume will be volume of cylinder plus volume of hemisphere. It will be pi r square h plus 2 by 3 pi r cube. The fourth one is a cylinder which is depressed by a cone. So the TSA will be CSA of a cone plus CSA of a cylinder plus area of circle, which is pi rl plus 2 pi rh plus pi r square. For volume, it's volume of cylinder minus volume of cone, which is depressed. So it will be 2 pi rh minus pi rl. And the first one will be a cuboid which is depressed by a cone, just like similar like the last one. So total surface area of a cube plus CSA of a cone minus area of circle gives the total surface area, which is 2 into LB plus BH plus LH plus pi RL minus pi r square. You may ask why you're subtracting the area of circle. You may look at the top of the object. You have a hole in it. So that's the thing that I'm saying as pi r square, which that we should subtract. And in volume, it's volume of cube minus volume of cone, which is depressed. So LBH minus 1 by 3 pi r square h. And in next, it's similar like that. There's cube and hemisphere is depressed, and TSA of the object is TSA of a cube plus CSA of a hemisphere minus area of circle. And volume is volume of cube minus volume of hemisphere. For TSA, the formula is 6a square plus 2 pi r square minus pi r square, where volume is a cube minus 2 by 3 pi r cube. Next up, we have ambient model problem mapping. It's basically the types of questions we get. So, first one, we have a toy, which is in the form of a hemisphere mounted by a cone. They've given that the radius of cone is equal to 3 centimeter, and the radius of cone and radius of hemisphere should be same, right? So height of the cone is 15 centimeter, and they've asked to find the TSA of toy. So the formula will be CSA of cone plus CSA of hemisphere, and it will be parallel plus 2 pi square. And next up, we have a chill pill capsule, right? They're given the entire height is 14 millimeters. The capsule is in a shape of a cylinder with two hemisphere at its each end. So they have given that diameter is 5 millimeter, which is same for hemisphere and cylinder. So they have asked to find the surface area of capsule, and the solution we will give is 2 into CSA of hemisphere plus CSA of cylinder, which is 2 into CSA of hemisphere is basically one sphere, right? So we can have it like area of sphere plus CSA of cylinder, but it's not really needed. So 2 into 2 pi r square plus 2 pi r h is formula. And next we have a pen stand in the form of cuboid with 4 depression holes, conical holes. So they given the dimension of cuboid, which is 15 into 10 into 3.5, and depression cut off 4 cones. Alright, so radius of cone is 0.5 centimeter and height of cone is 1.5 centimeter. Now there is 4 cones. To find this volume of the pen stand, and the solution will be volume of cuboid minus 4 into volume of cone, because there's 4 cones. So LBH minus 4 into 1 by 3 pi r square h. And next is a normal like a pencil like object. It is given us the diameter of the cone is 4 centimeter, and it should be the same as the cylinder. Right, the diameter of the cylinder should be 4, and the height of the cone is 6 centimeter and height of the cylinder is 10 centimeter. So total surface area of the object is to be found. Note it, there's a base under it, so we gotta add a area of circle. Alright, and CAC of cone plus CAC of cylinder plus area of circle will be the solution. It can be written as pi RL plus 2 pi RH plus pi square. In MPM, next up we have a cylinder mounted on a hemisphere, as the diameter is given as 14 centimeter and the height of the vessel is 13 centimeter. To find the volume, we have to do the formula volume of cylinder plus volume of hemisphere, which is pi r square h plus 2 by 3 pi r cube. Next, we have a shape in the form of a cylinder with 2 cones attached to its 2 ends. They have given us the diameter as 3 centimeter and length of the whole model as 12 centimeter and height of the cone as 2 centimeter. So as volume to be found, and the formula will be volume of cylinder plus 2 into volume of cone, as there is 2 cones. So it's written as pi r square h plus 2 into 1 by 3 pi r square h. Next we have a tent with a height of cone 5 meter and height of cylinder as 8 meter and diameter is 24 meter, which is same for the same for the cone and for the cylinder. So we have to find the TSA of the tent. For TSA, we have gotta do CSA of cone plus CSA of cylinder of tent, which is pi RL plus 2 pi RH. And next, we have a cylinder depressed by a cone given as the height of the solid. The solid means the full height. So 2.4 centimeter. The height of the cone and cylinder is gotta be same. So the height of the cone and cylinder both are 2.4 centimeter. The cone is depressed and the diameter of the object is 1.4 centimeter, which is equal for cone and cylinder. They've asked the volume of remaining solid. It is depressed, right? So that will be remaining. The volume of remaining, that's what they ask. So the volume of remaining is volume of cylinder minus volume of cone, which is pi r square h minus 1 by 3 pi r square h. Now I will show you some example sums from the MPM. The first one, the question is written as a toy is in the form of a cone of radius 3 centimeter mounted on a hemisphere of same radius. The height of the cone is 15 centimeter. Find the total surface area of the toy. Now, they're given the radius is 3 centimeter and height of the cone is 15 centimeter. Find its total surface area. You can see the reference diagram, and the formula is going to be CSC of cone plus CSC of hemisphere, which is pi RL plus 2 pi RH. I'll substitute it. I'll substitute it for radius and L, and for another radius. Both radius are the same. So pi into 3 into 15 plus 2 into pi into 3 square. So I get 45 pi plus 18 pi, which gives 63 pi. So 63 into 22 by 7, 7 cancels 63, and we get 90 to 22, and we get 198 centimeter square, which is the total surface area of the toy. Next, the question is, a capsule has a cylinder with 2 hemispheres in its ends. The height of the entire capsule is 14 mm and the diameter is 5 mm. Find the total surface area of the capsule. They are given the entire height and diameter and radius. Radius, we gotta find it. And the height of the cylinder is 14 minus 2 into 2.5, which is 2 into radius. So we get 9 mm, and you can have the reference diagram. We have to find the total surface area. We have the formula as 2 into CSA of hemisphere plus CSA of cylinder, which is area of sphere plus CSA of cylinder. Two hemispheres, alright, two CSA of hemispheres. They put together are area of sphere. So area of sphere plus CSA of cylinder gives 4 pi r square plus 2 pi r h. So we substitute it and we have 4 pi into 5 by 2 into 5 by 2 plus 2 pi plus 5 by 2 into 9. So we have 25 pi in this left side and 45 pi in here. We add it, we get 70 pi. So 70 into 22 by 7, 7 cancels, and 10 into 22 is 220 millimeter square. So the answer is total surface area of capsule is 220 millimeter square. Question is, a pen stand in the shape of a cuboid of dimension 15 into 10 into 3.5 with a 4 conical repression of radius 0.5 cm and depth 1.4 cm. Find the volume of the pen stand. Dimension of cuboid is given as 15 into 10 into 3.5 and height of the cone is 1.4 and radius of the cone is 0.5, and there is 4 cones. You have the reference diagram to see. We have to find the volume of the pen stand. So the formula will be volume of cube minus 4 into volume of cone, because there's 4 cones. So LBH minus 4 into 1 by 3 pi square h. So we substitute it and get it as 15 into 10 into 3.5 minus 4 into 1 by 3 pi into 0.5 square into 1.4. So we multiply everything and subtract 525 minus 1.47. We get 523.53 centimeter cube, which is the volume of the pen stand. Next, the question is, an object with a cylinder of diameter 4 cm with height 10 cm mounted by a cone of same diameter and height of 6 cm. Find the total surface of the object. So we have to find the total surface of the object. They were given the diameter is 4 cm, which is equal to the cone and the cylinder. Height of cone is 6 cm and height of cylinder is 10 cm, and the slant height of cone, which is L, is 2 root 10. Alright, so you can look at the reference diagram, and the formula will be CSA of cone plus CSA of cylinder plus area of circle, because we add the area of circle because there's a base for the diagram. If you look at it, there's a base for the object, there will be a base. So we substitute it and we get pi into 2 root 10 plus 2 pi into 2 into 10 plus pi into 2 square. And I get 4 root 10 pi plus 40 pi plus 4 pi, and we substitute everything and we get 196.02 centimeter square, and the answer is the TS of the object is equal to 196.02 centimeter square. The question is, a vessel in the form of a hemisphere mounted by a cylinder where height of the vessel is 13 centimeter and the diameter is 14 centimeter. Find the volume of the vessel. They have given the entire height and the diameter. The radius is 14 by 2, which is 7, right? So the height of the cylinder should be the entire height minus the radius. So we get 6 centimeter as the height of the cylinder. So we have to find the volume, and the formula is volume of cylinder plus volume of hemisphere, which is pi r square h plus 2 pi 3 pi r cube. We substitute it and we get pi into 7 square into 6 plus 2 by 3 pi into 7 cube. And we substitute everything and we get 294 pi plus 686 divided by 3 pi, and we get 924 plus 2156 divided by 3. At last we get 1642.67. So the volume is 1642 plus 0.67 centimeter cube. That's the volume of the vessel. The question is, a model shaped like a cylinder with 2 cones attached to its ends. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of the model. Height of the cone is 2 cm and it's given, and there's 2 cones, and the height of the whole the height of the whole model is given as 12. So the height of the cylinder is the height of the whole model minus two cones height, alright, two cones height. So 2 into 2. So 12 minus 2 into 2 is 12 minus 4, which gives 8 centimeter. You can have the reference of the diagram to look at it. So the diameter is 3, so radius is 3 by 2. So we have to find the volume, and the formula will be volume of cylinder plus 2 into volume of cone, because there's two cones. So pi r square h plus 2 into 1 by 3 pi r square h. So we work on it and we get pi into 3 by 2 into 3 by 2 into 8. And we cancel things, and plus 2 into 1 by 3 pi into 3 by 2 into 3 by 2 into 2. And we get 18 pi plus 2 into 3 by 2 pi. And we get 18 into 22 by 7 plus 2 into 3 by 2 into 22 by 7. And we get 396 plus 2 into 66 divided by 7. And we get 462 divided by 7. And we cancel it, we get 66 centimeter cube, which is the answer. The answer is the volume of the model is 66 centimeter cube. Question is, a tent is in the form of a cylinder of height 8 meter and the diameter is 24 centimeter, mounted by a cone of same radius and height 5 meter. Find the TSA of the tent. So they are given that the height of the cylinder is 8 meter and the height of the cone is 5 meter and the slant height is 13 meter. Alright, slant height of the cone, which is the L, and diameter is 24, so radius is 24 by 2, which is 12. And we have to find the total surface area of the tent. The tent won't have a base, right? Normally you go to circus or whatever, you'll have no cloth under it, right, as a base. So we have to find the CSI of cone plus CSI of cylinder, which is the formula. So pi RL plus 2 pi RH. I substitute it, and pi into 12 into 13 plus 2 pi into 12 into 8. I get 156 pi plus 192 pi, which is 348 pi, which is 348 into 22 by 7. I get 1093.71 centimeter square. So the TSA of 10, which is total surface area of 10, is 1093.71 centimeter square. Question is, from a solid cylinder whose height is 2.4 centimeter and the diameter is 1.4 centimeter, a cone of same height and diameter is carved out. Find the volume of the remaining part. So that they have given as height is 2.4 centimeter and diameter is 1.4 centimeter. So the height of the cone and the cylinder is same, it's 2.4, and the diameter is also same, it's 1.4. So we have to find the volume of the remaining object, alright? So we have the formula as volume of cylinder minus volume of cone to find the volume of remaining. So we substitute it and we get pi 1.4 by 2 square into 2.4 into 2 by 3. So we have pi into 1.4 by 2 into 1.4 by 2 into 2.4 into 2 by 3. We cancel everything and we get 44 into 0.1 into 0.56 as 2.46 centimeter cube. So the answer is 2.4 centimeter cube. 2.46 centimeter cube. The references I have used is 10th Max NCERT textbook and our link saitechinfo.net and State Board Maths textbook class 10. Thank you, and for more like this, use the link given below saitechinfo.com.